Most people have no idea that one of the smartest cooling systems ever invented is sitting on top of millions of old buildings, doing absolutely nothing today. A spinning metal dome powered by nothing but wind and heat once helped cool homes, warehouses, and factories across America without using a single watt of electricity. No motors, no electronics, no fuel, just physics. And yet somehow, despite energy bills rising every year, we quietly stopped using them. They're called turbine ventilators or whirlybirds. And according to real-world testing, these simple devices can reduce attic temperatures by as much as 37 degrees Fahrenheit and lower cooling costs by nearly 15%. That's a massive difference for something that costs less than many smart home gadgets people buy without thinking twice. So if they work so well, why did they disappear? Were they actually outdated, or did modern housing simply move in a different direction? And more importantly, should we bring them back? To understand why turbine ventilators mattered so much, we need to go back long before electricity even existed. Humans have been trying to cool buildings naturally for thousands of years. Ancient Persian architects designed giant wind catchers, tall towers that captured desert breezes and pushed cool air into homes while pulling hot air out. These structures worked so well that some buildings stayed surprisingly comfortable even in brutal desert heat. Meanwhile, during China's Tang Dynasty, Buddhist monks used natural ventilation channels inside cave complexes to regulate underground temperatures and improve airflow. Even medieval European builders treated airflow as a critical part of architecture. Back then, people understood something modern construction sometimes forgets. Buildings need to breathe. As cities grew during the Industrial Revolution, natural airflow wasn't enough anymore. Factories, hospitals, and mines needed stronger ventilation systems to remove heat and dangerous gases. Engineers created massive fans and steam-powered systems, but they required fuel, maintenance, and expensive infrastructure. Then in 1910, engineer Samuel Ewart introduced a much simpler solution: a spinning rooftop ventilator powered entirely by wind and rising heat. It needed no electricity, no fuel, and no manual operation, while helping solve one of the biggest hidden problems inside homes: trapped attic heat. During summer, sunlight pounds directly onto a roof for hours. That heat transfers into the attic, turning it into a giant thermal oven. In many American homes, attic temperatures can exceed 150 degrees Fahrenheit. And that heat doesn't stay trapped above the ceiling, it slowly radiates downward into the living space below. That means your air conditioner has to work harder just to maintain the same indoor temperature. According to the US Department of Energy, every single degree increase in attic temperature can raise your cooling load by up to 4%. And here's where it gets even worse. In many homes, the ductwork carrying cold air from the AC system runs directly through that scorching attic. So before the cooled air even reaches your bedroom or living room, it's already heating back up again. That's why attic ventilation matters so much. The goal is simple: remove the hot air before it can transfer downward into the home. And turbine ventilators do this using 3 powerful physics principles working together at the same time. The first principle is Bernoulli's principle. As wind moves across the curved fins of the spinning turbine, the air speeds up. When air velocity increases, pressure drops. That creates a low pressure zone inside the turbine, which actively sucks hot air upward and out of the attic. Unlike a basic static vent that simply waits for air to drift out naturally, the turbine ventilator actually uses wind energy to create suction. The stronger the wind, the harder it works. But the really fascinating part is that these systems can still function even when there's very little wind. That happens because of something called the stack effect. Warm air naturally rises because it's less dense than cool air. So even on calm days, heat inside the attic slowly moves upward toward the turbine. As hot air escapes through the top, cooler outside air enters through soffit vents near the lower edges of the roof. This creates a natural airflow cycle without using any power at all. Then there's the third principle: the Venturi effect. As air squeezes through the narrow gaps between the spinning fins, its speed increases even more, reducing pressure further and accelerating the exhaust process. All 3 effects combine into one continuous passive cooling system. And surprisingly, it works really well. Research from the Air Infiltration and Ventilation Center found that turbine ventilators increased attic ventilation rates by an average of 15% over a full year. Under ideal wind conditions, improvements reached nearly 50%. Another study in the San Diego area found properly installed turbine systems reduced peak attic temperatures by up to 37 degrees Fahrenheit. That translated into average cooling cost reductions of about 14.6%. Those are serious numbers. Even a standard 12-inch turbine ventilator can move between 250 and 350 cubic feet of air every minute with just a 5-mile-per-hour wind. Larger 14-inch models can push as much as 500 cubic feet per minute. And remember, all of that airflow happens without consuming electricity. Every bit of energy savings becomes pure efficiency. So naturally, you'd assume turbine ventilators would be everywhere today, but they aren't. The decline of turbine ventilators came down to 3 things: performance limits, modern housing design, and appearance. Studies found that a single turbine often couldn't move enough air for larger modern homes, especially in hot climates where ventilation demands are much higher. Today's homes are also tighter and more energy efficient than older houses. Many require multiple turbines to cool effectively, making installation more complicated and less practical compared to newer ventilation systems. Reliability became another major problem. Over time, turbine bearings could wear out from dust, moisture, and corrosion, causing loud squeaking or grinding noises. Cheap models made things worse, giving turbines a reputation for being noisy, unreliable, and high maintenance. There's also a hidden issue called short-circuiting. When turbine ventilators and ridge vents are installed together, the stronger suction from the turbine can reverse airflow through the ridge vent. Instead of pushing hot air out, the vent can start pulling rain or snow into the attic. Because of this, roofing professionals usually recommend using only one system, and most builders choose ridge vents. Another reason is appearance. Modern neighborhoods prioritize clean roof lines and curb appeal. Ridge vents are almost invisible, while turbines stick out above the roof. Many homeowners associations even restrict or ban them for aesthetic reasons. Modern energy codes also played a major role. Today's airtight homes rely on controlled mechanical ventilation systems. Since turbine performance depends on wind and temperature, builders gradually move toward more predictable ventilation solutions. But here's the interesting part. That doesn't mean turbine ventilators stop being useful. In hot, windy regions like the American Southwest, Gulf Coast, and large parts of Australia, turbine systems can still be one of the cheapest and most energy-efficient cooling upgrades available. A basic 12-inch turbine usually costs between $20 and $100 for materials. Professional installation typically adds another $100 to $300 depending on roof design and complexity. For many average-sized homes, 2 properly installed turbines can noticeably reduce attic heat buildup. In warmer climates, homeowners can often recover installation costs through energy savings within 3 to 5 years. Beyond lowering energy bills, turbine ventilators also help remove trapped moisture and excess heat that can damage roofing materials over time, but they are not ideal for every home. In colder climates, snow and ice can freeze the spinning fins, while modern airtight homes often rely on carefully balanced mechanical ventilation systems instead. That's one reason ridge vents became more popular. A full-length ridge vent spreads airflow evenly across the roof, avoids attic dead zones, and has no moving parts, meaning no noise, no maintenance, and no mechanical failures for decades. So, did turbine ventilators disappear because they failed? Not really. They were actually a smart and effective cooling solution for older homes, especially in hot climates. But as modern houses became more airtight, visually cleaner, and dependent on advanced mechanical systems, turbines slowly faded from mainstream construction. Still, the idea behind them remains powerful today. Using natural airflow instead of electricity to cool buildings is one of the most efficient energy-saving concepts ever created. Sometimes, old technology doesn't disappear because it stopped working. It disappears because the world around it changed.